at Facebook looking at code. And so I developed a lot of opinions about software safety, about programming language design, seeing where programming languages set programmers up for failure and where it helped them. The most scarce resource in the world isn't time, and it's not money, but it's human brain power. And like a lot of what human brain power is being used to do is to build software. And so if you can magnify brain power, do more per unit time, then like that's one of the most impactful things that you can do. I did my homework in terms of looking at other options. And basically the decision to create a new language came from the fact that we didn't think any of these options was quite appropriate. There are some really essential tasks that a smart contract language needs to do that don't exist in conventional languages. And so that was a lot of the basis why we decided to do something new. The company started in November 2021, so definitely something I remember was hacking on Sui on Christmas Day and getting the first end-to-end transaction that was calling move code going all the way through and working. We started off with just being able to do object transfers, which happen outside of move, but that was the first time we had a move call that worked all the way through. That was pretty cool. That was a huge milestone because, it's the first public distributed network running Sui. This is the first time where we can really establish that developer feedback loop because now we have a live network. People can publish code. People can use our CLI. They can use our SDKs. We can get feedback. You see someone doing something with the language that you hadn't thought about, or you see someone discovering it for the first time and saying like, this thing is really cool. At that point, I think it feels really good. And I feel a lot of pride to see like your life's work and sort of your intellectual baby taking on a life of its own and growing up a little bit. Programming languages, they're not like natural languages. They don't do everything. They're supposed to do one particular kind of task and do that task really well. The reason a dedicated language is required for this is because these are tasks that are not supported in conventional programming languages. There are three unique differentiating features of Move on Sui. So the first one is the object-based data model. Objects are the fundamental building blocks in Sui Move. It's just a big database of objects. And the kind of task that Move is targeted at is programming with scarce objects. Objects that have conservation properties like, oh, you can't accidentally throw them away. You can't copy them. They have strong ownership transfer. And so with Sui, like you get all of these things basically for free. Like defining an object is as easy as you define a struct, it has some fields, it has a globally unique ID, so you have a way to refer to it from your inside of Move code. In the front end, this ID stays the same as the object moves across accounts and travels across time. It gives you a way to always refer to it. And it's not something that the programmer has to do. It's just like every object gets one of these for free. The first change we made when we came out of Libra was to add this object-based data model. The second feature that I think is really interesting is something called programmable transaction blocks. When you have a transaction, it calls a move function, and that's sort of all that it does. And what programmable transaction blocks let you do is, instead of just calling one function, you call a function, and then you call another function. You can pass objects from earlier in the transaction block into functions later in the transaction block. It lets you do composability on the fly from the front end. And so this is probably the favorite feature of Sui builders because it just lets them do so much more than they could if you can call only one function at a time. The third big differentiator is something called dynamic fields, where with move objects, of course, you declare a set of fields, static types, you write to them, you can update them. But what dynamic fields do is they let you add additional data to a move object on the fly. Maybe you publish an object and then you decide later, I'd actually like to add this other field to it that I didn't anticipate needing at the beginning, but without having to rewrite my old code or migrate the old migrate the old object data. You can mix and match objects in ways that maybe the original creator didn't intend, and like create these mashup experiences that are really delightful. So like for game developers, I think the dynamic fields is one of the features that they find the most compelling. Say you have a character in a game and they've got an inventory that consists of all these heterogeneous types of objects. The way you would express that in Sui is that the hero character is an object, and then maybe their sword is another object, and it's connected to the hero via a dynamic field that says, hey, here's what I'm holding in my hand. And then, if they have some boots, there's another dynamic field that says, here's what's on my feet. You don't have to know in advance that this is what's going to be needed. You have a lot of flexibility in how you can mix and match things. And there's been some really impressive stuff that Sui builders have done, combining these features to give you a lot more richness and power. We've always been pumped about seeing what our builders do, like leveraging Sui in ways that we didn't expect, figuring out how to combine features in creative ways. We really care about making Sui the place where the best builders build. There's the new transfer to object feature. I want to see what folks are going to do with the random beacon. I would like to see with some of the extensions we're making to ZK login that allow you to do multi-sig accounts that incorporate ZK login as one of the authentication features. I'm constantly surprised and delighted by what the Sui community creates, and I'm really excited what you all are going to do in this hackathon. I am the creator of Move. I'm the first person to join the Libra project and be given the assignment of, hey, Libra is going to have smart contracts. It's important to have safe programmability on the blockchain, like figure out what to do with that. Someone pulled me into a room and pitched me, and like I knew right away, hey, here's this big effort that Facebook is doing. It's very ambitious. We have this mission of financial inclusion that I immediately identified with. They brought me in as the programming languages expert, and this was sort of my road into blockchain. I spent a number of years at Facebook looking at code, and so I developed a lot of opinions about software safety, about programming language design, seeing where programming languages set programmers up for failure and where it helped them. The most scarce resource in the world isn't time, and it's not money, but it's human brain power. And like a lot of what human brain power is being used to do is to build software. And so if you can magnify brain power, do more per unit time, then like that's one of the most impactful. My homework in terms of looking at other options. And basically the decision to create a new language came from the fact that we didn't think any of these options was quite appropriate. There are some really essential tasks that a smart contract language needs to do that don't exist in conventional languages. And so that was a lot of the basis why we decided to do something new. The company started in November 2021, so definitely something I remember was hacking on Sui on Christmas Day and getting the first end-to-end transaction that was calling Move code going all the way through and working. We started off with just being able to do object transfers, which happen outside of Move, but that was the first time we had a Move call that worked all the way through. That was pretty cool. That was a huge milestone because, it's the first public distributed network running Sui. This is the first time where we can really establish that developer feedback loop because now we have a live network. People can publish code. People can use our CLI. They can use our SDKs. We can get feedback. You see someone doing something with the language that you hadn't thought about, or you see someone discovering it for the first time and saying like, this thing is really cool. At that point, I think it feels really good. And I feel a lot of pride to see like your life's work and sort of your intellectual baby taking on a life of its own and growing up a little bit. Programming languages, they're not like natural languages. They don't do everything. They're supposed to do one particular kind of task and do that task really well. The reason a dedicated language is required for this is because these are tasks that are not supported in conventional programming languages. There are three unique differentiating features of Move on Sui. So the first one is the object-based data model. Objects are the fundamental building blocks in Sui Move. It's just a big database of objects. And the kind of task that Move is targeted at is programming with scarce objects. Objects that have conservation properties like, oh, you can't accidentally throw them away. You can't copy them. They have strong ownership transfer. And so with Sui, like you get all of these things basically for free. Like defining an object is as easy as you define a struct, it has some fields, it has a globally unique ID, so you have a way to refer to it from your inside of Move code. In the front end, this ID stays the same as the object moves across accounts and travels across time. It gives you a way to always refer to it. And it's not something that the programmer has to do. It's just like every object gets one of these for free. The first change we made when we came out of Libra was to add this object-based data model. The second feature that I think is really interesting is something called programmable transaction blocks. When you have a transaction, it calls a move function, and that's sort of all that it does. And what programmable transaction blocks let you do is, instead of just calling one function, you call a function, and then you call another function. You can pass objects from earlier in the transaction block into functions later in the transaction block. It lets you do composability on the fly from the front end. And so this is probably the favorite feature of Sui builders because it just lets them do so much more than they could if you can call only one function at a time. The third big differentiator is something called dynamic fields, where with move objects, of course, you declare a set of fields, static types, you write to them, you can update them. But what dynamic fields do is they let you add additional data to a move object on the fly. Maybe you publish an object and then you decide later, I'd actually like to add this other field to it that I didn't anticipate needing at the beginning, but without having to rewrite my old code or migrate the old object data. You can mix and match objects in ways that maybe the original creator didn't intend, and like create these mashup experiences that are really delightful. So like for game developers, I think the dynamic fields is one of the features that they find the most compelling. Say you have a character in a game and they've got an inventory that consists of all these heterogeneous types of objects. The way you would express that in Sui is that the hero character is an object, and then maybe their sword is another object, and it's connected to the hero via a dynamic field that says, hey, here's what I'm holding in my hand. And then, if they have some boots, there's another dynamic field that says, here's what's on my feet. You don't have to know in advance that this is what's going to be needed. You have a lot of flexibility in how you can mix and match things. And there's been some really impressive stuff that Sui builders have done, combining these features to give you a lot more richness and power. We've always been pumped about seeing what our builders do, like leveraging Sui in ways that we didn't expect, figuring out how to combine features in creative ways. We really care about making Sui the place where the best builders build. There's the new transfer to object feature. I want to see what folks are going to do with the random beacon. I would like to see with some of the extensions we're making to ZK login that allow you to do multi-sig accounts that incorporate ZK login as one of the authentication features. I'm constantly surprised and delighted by what the Sui community creates, and I'm really excited what you all are going to do in this hackathon. I am the creator of Move. I'm the first person to join the Libra project and be given the assignment of, hey, Libra is going to have smart contracts. It's important to have safe programmability on the blockchain, like figure out what to do with that. Someone pulled me into a room and pitched me, and like I knew right away, hey, here's this big effort that Facebook is doing. It's very ambitious. We have this mission of financial inclusion that I immediately identified with. They brought me in as the programming languages expert, and this was sort of my road into blockchain. I spent a number of years at Facebook looking at code. And so I developed a lot of opinions about software safety, about programming language design, seeing where programming languages set programmers up for failure and where it helped them. The most scarce resource in the world isn't time, and it's not money, but it's human brain power. And like a lot of what human brain power is being used to do is to build software. And so if you can magnify brain power, do more per unit time, then like that's one of the most impactful things that you can do. I did my homework in terms of looking at other options. And basically the decision to create a new language came from the fact that we didn't think any of these options
Hello, everyone, and welcome to another episode of the Sui Overflow workshop series. Unfortunately, Harrison is not going to be able to make it today, so I'll be helping him out here. My name is Z. I'm a developer relations engineer at Sui. So today's workshop will be a little bit different. We will have a code along session here with our engineer here, Alex, who's going to show y'all how to build a kiosk related app. I've already pinned a comment in the section for those of you that want to join the Zoom call and interact more directly with Alex. But also feel free to stay on the YouTube link. It works just fine as well. I'll read the comments and relay it to the presenter there. And I think without further ado, let me present the I guess the Zoom conference here. Okay, cool, Alex. I think you can take over now. Okay, I can't seem to figure out a way to stream the audio from the Zoom call here. What would be the best way here? So, yeah, the audio here is a little bit glitched. It's working now. I mean, can Alex? Can you say something? If everyone on YouTube can hear Alex, type 1 please in the chat. J9U, can you hear Alex talk like just then? Yeah, you still cannot. Yeah, we still cannot hear Alex on YouTube. What would be the best way to do here? Well, I think yeah, you still cannot hear Alex. I think one way to do this is probably just have Alex join the StreamYard here. Alex, do you have access to this StreamYard? Here, let me send it to you. I think you should be able to do this and the Zoom call at the same time. On Slack. And I think you just need to mute the tab so you don't hear yourself twice. Yeah. Just give us a minute here. I'm trying to get Alex's voice on YouTube as well. Are you able to join, Alex, or no? Here, I can invite you. Okay, perfect. All right, yeah.
Okay. Okay. Is everybody able to hear me now? Hello. Okay. Okay, welcome everyone again. So the project is going to be kiosk related. I will be focusing mostly on how do I go about writing a move contract. It will be mostly move and the part of the Web2 that has to do directly with move, that is PTBs, and how do you interact with the blockchain and the Kiosk SDK. So the full code is available over here. You should already have the link, but in case you don't have it, you can ask us at any point in time. So at solution engineering, whenever we have we have to create a new contract, we have a request for a contract. We start with a design doc usually. This implies that you're a bit more advanced in Move. You can be a total beginner, won't be able to make a design doc, but it's a very good practice to do it. Even if you're not sure what you're going to write, you can just leave many things empty. But it helps. A design doc in our experience helped us a lot to actually see potential bugs, to understand the relationship with each part, and make sure that we had the code was like more compact and we didn't have a lot of unneeded or faulty code. So I added in the README, usually for design, depending on how big the project is, we may use C4 diagrams. In this case, the C4 diagram is like fairly simple. We have a user that can buy our NFT or sell or trade them on a marketplace. And so for smaller project, just a sequence diagram is a lot better. In this case, which is a simpler example, we just have a user and a marketplace. The user can see our NFT will be called trading pack, and maybe in the future it will be more complete with pack opening and randomness. So the user can see all the trading packs. He can buy the trading pack on the primary market, which is from the creator us. He can list on the secondary market his trading pack, and he can buy trading packs from other users. I use the trading pack and not the cars that are inside. There's an NFT right now because a trading card would have a lot more fields, and I wanted to focus mostly on the move code and not writing too many fields and stuff like that. After we're done with the diagrams, and we have a diagram that actually captures then our either the product manager or whoever is in charge of product agrees that this is what should happen, then usually we move to a move design where we write all the definitions of the structs and the functions that we're going to use. Let's have a look at this. So we're going to have two modules in this case. This is an admin module. This is a fairly standard pattern where we have an admin cap that is the main capability that will be for all our modules in this package. Now, what is a capability? A capability is a special object that allows you it gives you privileges. So it can give an address privileges, and we do that by making sure that not many of these objects can be minted. So this admin cap, in this case, it will be inside the init. It will be created only once inside the init. It will be sent to the caller. And the init function in move is a function that runs only during publishing. So the one who publishes the contract will become the admin. And we will make sure to gate with this capability. We'll see how we are going to do that. Any function that should only be called by the admin. We also allow the burn. This is just to show you that it's a very good idea on Sui whenever you create an object to allow the object to be burned. You may want to gate. So in this case, you already need to own an admin cap. So not everyone can burn an admin cap. If you don't own it, you cannot do it. But it's a very good idea to have a burn function because this will return you a lot of gas back. On Sui, gas works in the following way. Whenever you call a transaction, you need computation cost. So for whatever the nodes, a validator will need to use in terms of RAM and CPU and so RAM and CPU, and this is just the computation cost. This usually is the most cheap part of the gas, and the other part is the storage. So whenever you need bytes on chain, whenever you store something on chain like a new object, then you're going to pay, say, 7,600 Bs per byte. But whenever you're burning an object, you're going to get 99% of what you paid for storage back. So this is why it's a very good idea to have a burn. Maybe in the future something will change in your product, in your roadmap, and you will not want to have an admin cap anymore or any other object that you create. It's very difficult to call functions by mistake since you won't be writing this on any PTB on the backend. So there is no security risk in this just being here. The main move contract will have a witness. This is a one-time witness in case we want to create a display. And with this, we can get a publisher. The publisher allows us to create the object display. This is the way that we control the image of the image and how explorers actually show our NFTs. A one-time witness, in this case, in Move, is a struct that has only drop, and its name should be the capitalized version of whatever the module is named. And this pattern is only used in init. So the function init usually takes only a single argument, which is the context. We'll talk about it, but it may take another new argument that it's the witness. So whenever he takes the argument over here, in the background, when init is being run, it will check that this trading pack name, when switched to lowercase, is exactly the same as this. And this is being used to show that some functions were called only once, like the publisher and the color. The publisher, and maybe when you create a treasury cap for a new coin. So we are going to have a min capability that will allow, it won't be the admin, will allow it will allow us to give other people the privilege to mint our NFTs. In this case, for those who are already familiar with the abilities, for this min cap, I only gave key, so this is not tradable. Anything that has key and store is tradable. Anything that has only key is not tradable. So the admin, we're using the admin cap, can mint the min capability, and whoever has a min capability can delete it. In this way, it makes easy. Usually this min capability will, in our case, in our scenario, it will be used by the backend. So the backend will mint on demand. But if the backend private key somehow compromised, we could use this delete min cap in order to delete the cap. Since it's not sendable, the worst case scenario is that a few of our NFTs are going to be minted. So our NFT, it's called Trading Pack. It has key and store, which means it's tradable. In this case, it's fairly simple. It has an ID. Everything that has key needs to have the first field an ID that is of type QID. It has a tier, and it has a season. It may have other, in the full project, it will have other fields like the number of cards, maybe a price, maybe the date that was opened or the date that it was issued. In this case, for example purposes, we kept it fairly simple. We have the present that we will talk about. We wanted, since we're using Kiosk, we wanted to be able to airdrop, and we will see that with Kiosk, airdropping needs a bit of special handling. So I'm using a struct that only has key. Again, it's not tradable, and it's wrapping trading packs inside. So whenever we want to airdrop a trading pack, the idea is that we will mint them. The admin, the one who owns the mint capability, will mint the trading packs, and then we'll put them in a vector inside this present. We will write a function that opens and destroys and gets the trading pack and make sure that these get inside the kiosk. So we have a mint that returns the trading pack. This is the standard function. Depending on the project, it may be called new. I prefer mint. I have a function that is more like a helper function, which is place and list to kiosk. This could have been made by written with the SDK, so everything from Web 2. But I wanted to show you the composability of PTBs and how you can combine first mint and then place and list to kiosk. So the idea is that we, as the creator, we will also have a kiosk. Everything that we mint will be placed and listed over there, and whatever is listed on that kiosk, it will be considered the primary market, the first source of getting trading packs, and then whatever is listed on the user's kiosk is the secondary market. The airdrop that will send a present to every user. So I need a vector of trading packs in order to construct the present, and I need a recipient address because I have to because the present has only key, and I will need to transfer it from within the function itself. this is another example that I have how you can mint many on the move side. Then we will see an example of how we can do this on the Web2 side. This is just a convenience in case we want to mint in order so we won't have to mint one by one every time we want to put more trading packs in the primary market. And the player will have two functions for the moment. Our users will have only two functions. One is the unwrap, which is the present. So they get a present, they present their kiosk, and we make sure that whatever is inside the present will get. So all this vector with trading packs will get inside the kiosk of the user. In this way, the kiosk is mainly used to ensure royalties. So if we don't put something inside the kiosk, and we want royalties ensured every time, then that won't happen. And last will be the open pack, because the way that we will create our kiosk, we will enforce a rule and we will create a transfer policy for our NFT that governs the way this will be traded. We will actually request that every time a trade happens, the NFT should be locked inside the kiosk, which means that you cannot take it out and put it in your address. So whenever you want to open a pack, that will imply that you need to burn it. And I will just show how you can unlock something from a kiosk. And this is why I'm going to use a shared object that holds some empty transfer policies, and that will allow me to do the unlocking, because this is the only way that then we can call the burn function in order to delete the trading pack. So with this being said, this is the design, and we can start coding. In general, the way that we usually start, it's the prerequisite is that you have the Sui CLI. My version right now is 1.23. I think it's the latest. And Sui move new. I will name it Overflow. And now we have an overflow. It has sources with overflow move, some initial, but I'm going to delete those, and a move tunnel. So the move tunnel in this case, it has the dependencies. The main dependency that every time we are going to use in every contract is the Sui library and the standard library of move. This is added by default. It's very difficult to write any move code without this. But if you need to depend on someone else's code, you can add that over here as well. I'm going to delete this now, because I'm not going to name it Overflow, neither the tests. We're going to create our own. Everything that you put inside sources, also I'm going to create a git ignore. Spell it correctly. Everything that you put inside sources is going to be your modules, and the test can be put wherever. So I'm going to ignore everything that starts with build. This is what happens when you do a Sui move build, and we will do it very shortly. The node modules that we're going to use on the Web2 side, and an env that will hold the private key of the backend in this case. So the first thing that I like to do, as soon as I'm ready, I like to do a Sui move build. This will download all our dependencies. Well, let me read. Let me start by writing admin.move. We said we're going to have an admin.move module. In this case, it's overflow admin. Sorry. And now we can do a single build. And now we have a build folder and it has all our dependencies. So we have the standard library over here, and we have the Sui library over here. You can check the code every time you're not sure on how to use a certain, how to call a certain function. So we can start with our admin. We need a struct. So the way I'm usually doing it, I'm writing first the struct. This is usually copy pasted. If we have a design doc, I just copy pasted from my design doc. We said it's going to have key and store, and it just needs a UID because it has key and store. So whenever I write something that it's not imported, usually I go and import it immediately, because if I forget about it, I will get an error when I'm trying to build. So in this case, I need a UID, and I know I'm going to need other functions from object, so I'm calling self. So this is the way you import and move. Usually you need the package name, the module name, and then whatever structs or functions. Usually I don't like to import functions. I only import the structs. You can tell that something is a struct because it starts with a capital letter, and you can tell that's a function because it starts with a lowercase letter. I don't like to import functions, and you will see how I use the object. I just like to import self, and since we imported self, we can do the following. I'm going to write the init function where we create the Let's talk about TX context. Again, we are adding TX context. This is not imported. I should import it. I'm going to need the TX context as well. So I import all of it and TX context the struct separately. This is an optional argument that you may add to any function. The newest best practice is that even if you don't need it, add it with a lowercase, with an underscore, which means it's not going to be a used variable. But I will leave this to you if you like it. The TX context helps. So if we are not sure what something does and we see it for the first time, I usually just go to the sources. I see that it was imported from TX context. I just check here for TX context, and then I go and check the struct itself. So the struct is over here. It has 4 fields. One is the sender, and it says the address of the user that signed the current transaction. So whenever a transaction is called inside the TX context, we know the address of the sender. We know the transaction hash, the epoch that this happened, the epoch timestamp, the timestamp that the epoch started at, and how many IDs were created. 99.99% of the cases, all that we're going to be needing is the sender. In this case, I want to create a new cap. The way in Move, we declare variables with let. This will be an admin cap. I just name it cap. And in order to create a variable, I just make an instance. In order to create a new cap, I'm going to create an instance of admin cap. I need a new ID. I need an ID, and this is the way I'm usually calling functions from other modules. I use the module name because I can do this because I have called self over here, and then the function. In this case, the function that I want is new. This creates a new UID. If you're not sure why and how this happens or where to find it, as long as you know that UID is part of object, the way you can check it is you go over here and check all the functions one by one, and you want to check the return. So I want a UID, so I need the return type to be a UID. Whenever I find that over here, this returns a UID, but this is not for me to call. This returns a UID, And this is a public function, so this is the one that I want to call whenever I want to get a UID. And then this works for every module. Whenever you need the new, you want a new struct, just check for the function that has it as a return type. So this is the capability, and then I will just transfer it. In it, it's being called whenever the module is published, so it cannot be included in any PTBs, and that's why it doesn't need even modifiers. So it's transfer, public transfer. This is a function that we call for everything that we want to transfer that has key and store. I want to transfer the cap, and I want to transfer it to whoever called this function, and this would be the publisher of the contract. So I need the TX context sender and give this TX. So in this way, I ensure that only an admin cap is ever being created. I will also write the burn function, and this is a public function that will allow us to burn, but I'm not writing any function that allows us to create an admin cap. In this case, I want to make sure that there is only one admin cap or none. I don't want them to be two. So what I'm writing now is the destructuring pattern. Whenever we want to destroy an object, we first write the struct name, and then we have to write every field. In this case, we have only the ID. If we want to save it under a new variable, we do it like this. If we think that we are not going to need it, that means that if we can drop it, we just write an underscore. If we want to keep the same variable name, we can just write ID like this. So in moves, structs have capabilities. Key implies that something has a new ID and it automatically becomes what we call an object. It's something that will be saved in the global storage and it can be read on the Explorer. Something that has store is also tradable and can be stored inside other objects. So this is the meaning of store. There are two more attributes: drop and copy. Drop means that over here, if this had drop, we could just have dropped it. So we could have said, I don't care about the ID. I destructured the admin cap and I don't care anymore. Drop means that at the end of the block, the value will go away. If it doesn't have, so this doesn't happen in general. If block is not there, drop is not there, and drop and key are incompatible, then this will fail. Copy and key is also incompatible. We can have an object with the same key, but copy means that we can have multiple values with of the same struct. So we can get a reference and turn it into a new value. So in this case, if I'm trying to build it now, because I have the idea over here, it's a struct that does not have drop. If it had drop, I wouldn't get this error, but now I'm going to get an error at least. And a good practice is to do this like quite often when you're writing code. Do a swim of build and make sure that your code is. So I'm getting an error. I'm getting many errors. But the main error that I want to show you is unused value without drop. So because ID does not have drop, I cannot stop the function over here. I have first to either to destroy this ID or to transfer it somewhere else. Whenever we burn something, we are also destroying the ID. This is object delete. ID is a function. And at this point is where you're going to be getting the rebate, because you're deleting an ID and you're dropping all the other fields that maybe the struct may have. I have another error over here. I think I have forgotten some semicolon. Let's check again. Oh, yeah, I'm not. Importing transfer. Yeah. CLS provided by default. So this is a new version of Move 2024 that just got out last week. I wasn't able to create all the workshop based on this on the Move 2024, but right now we are intending to add private structs and enums, so we will have to be declaring all abstracts with public from now. Transfer seems to be provided by default. You used to have to import everything. This alias is provided by default. So and this alias is provided by default. Let me check. I will turn the edition to legacy because I hope. So now I will name this. Yeah, and now public is. And most probably I will rewrite. I will create on the GitHub a new branch that will have everything in the new Move 2024. I didn't want to use it because it's still in beta version. But whoever is experienced in Move is feel free to experience with it. It's a lot more convenient than what we're going to see now. So now everything compiles. We have an admin. And we're going to use this track in all of our other modules. I'm going to create the trading pack module now. And allow you to catch up and maybe see if we have any questions.
Any questions from YouTube or from Zoom itself? We have, I think I see one. Yeah, give me 1 second. No, that was, I think, from the Move 2024 issue before. Sorry, I didn't catch that, Nick. Any other things? Okay. Did we completely lose everyone here, or Alex? I think maybe it's good to have a separate branch here, and then just commit it to the same repo, so that way we can kind of have people follow along.
Right. So would you like me to create it now?
Yeah, just create another branch. I'll link your repo.
Okay.
So this is the link. I think people on YouTube should be able to see this now, and I'm going to also type it in chat. And also on Zoom as well.
I think I would have to rename this Overflow then.
No, well, you could just like.
Will it allow me?
Yeah. Well, I guess it's another. Oh, never mind. It's another. It's like a brand new repo, right?
Yeah.
Okay. Okay.
But I can commit and I can add all the branches later.
Yeah. You can do that late. You can do that later.
I will do it later. I don't even have a Git over here.
Okay.
But I have, so in my repo, if you go to part 0, I have everything. Let me show you. So in the repo, I have part 0. So we are done with the part 0 and part 1 right now. Part 1 is the admin. And then part 2 will be, and part 3 will be the trading, the other module that we're going to write. The rest will be on the web design. So everything, I'm following the same steps, so you can follow along. If you want to go copy paste it, just go to part 1 and copy paste everything. That's it.
Okay, so for everyone there, to go to the link that I just sent, and then go to the branch of part 0, and it should be in the same step as Alex doing right now.
So I have a few more. I have a few more. Usually, we add comments, which I didn't do, but it's a best practice. So that would be the only difference from the repo and what I'm writing right now. I may skip some comments. So I will give you 2 more minutes.
Yep, 1 more minute here. Okay, you can proceed.
Okay, great. So this is a new module. I will copy paste all the imports, so I don't have to write them every time I encounter them. But as I said, usually as I write the code and I encounter some new struct or some new function that I'm calling, I just go and add it to the imports. The practice is that imports are on top, but if it makes sense for you, you can add them, especially in test or somewhere where you would like to use them just once. You can add them even inside the function. And because I intend to create a display and I will need a publisher, I'm going to have a witness, a one-time witness. So this has to be capitalized letters of this thing. So it's a struct that has only drop. And I'm going to create an init function that will create a publisher and send it to the caller. With the publisher, we will be able to create a display. So we also need a publisher for the trading policies, transfer policies. And as you have, as I have shown in the design, I'm going to have a shared object that I will not allow. It will be readable by everyone, but I will allow access to it in very special cases. This is a shared object, so it doesn't matter if it has key or store or just key. So we are going to have a kiosk that is considered our primary market. It will be our own kiosk, and this is the place that all the new trading packs, the new limited trading camps will appear. So we are going to have also an empty policy that allows us to unlock items from a kiosk. This for trading pack, which I haven't defined yet. And a policy always comes with a policy cap. Let's define our main NFT as well. And please know that it doesn't really matter the order in which you define. So this again would be copied. Usually it would be copied directly from the design doc as it is, if we did a good design doc. If we didn't do a good design doc, again, it's a very good idea to write your code and then just go and write down the definition and design doc and look over it and make sure that all the connections. Movie is very secure by itself, so the mistakes always happen in the logic of the contract, where you might have forgotten to gate a function that needed to be gated, or you're doing something that can be abused just for function calls. So that is why it's best to have a design doc where you don't have all the fields and all the unnecessary commands, and just check the connections between each function, who is allowed, who is not allowed, and when it is called, or just see the attributes and make sure that they are the ones that you want for each struct, so you don't introduce unnecessary bugs. So we are going to have an ID, a tier, and a season. This will be our main NFT. And over here, I'm going to create the publisher first in the init. This is going to allow me to create a new central object, and it's going to allow me to create all the transfer policies that I need. Publisher, it's inside package, and the function is claim. Again, if you're not sure where you can find it, but you know that you need the publisher, you just go to the package module and check which function is returning a publisher type. Types can be inferred. In this case, we can also just write it. I don't think I'm importing it. So if I write it, it will error. So you're going to need the witness. We want to, in this way, we ensure that the publisher is only created once. I'm going to create a kiosk. This will be our main kiosk. Again, we only need one. This could have been done in the Web2 side, but in this case, I feel it's more convenient to do it in the init and make sure that everything is right. It's everything needed for the contract to run as I want it to run. Is ready. I'm going to create a new policy. I name TP. So because transfer policy I feel is very long, you can do an alias. So I say self as TP. Trading pack. So if you check the transfer policy over here, since we want the transfer policy, and we check which function returns one. So this function new returns the transfer policy and the transfer policy cap. We see that it needs type arguments. So this is how I know that over here I have to give something. Transfer policy is an object that holds inside rules that govern the way that an NFT is being traded. So every time transfer policy is specific to an NFT, and you need to pass its type inside here in new. So the compiler will know which NFT we're trying to create a policy for. You will need to show the publisher to prove that you are the one that published this contract, so you're considered the creator. And the object that I'm going to share, my naming is pretty lackluster, so I just named it central. It can be, I'm pretty sure you can find a lot better names. It needs an ID, and ID is object news. We're in the context. And if we check, we need a kiosk app. We have it over here. We are going to be using it in specific scenarios. We need an empty policy. In this case, the name don't coincide, so I have to write it more explicitly. And we need a policy cap. In this case, the name coincides, so I don't have to write it twice. This is more like a JavaScript field. So having this, all I need to do now is transfer the objects that do not have drop. So I have to transfer the publisher. And I'm going to transfer it to the sender. And then I'm going to share the objects I'm sharing. I'm going to share the central object. And even though it's shared, I will make sure that there is no access to it, except by certain functions that can only be called by privileged persons. And lastly, I'm going to need a public share object. So Kiosk. It doesn't show over here. I'm not sure why. So Kiosk has both key and store. If it has only key shared object, if it has both key and store, you need a public share object. So I'm sharing the kiosk. And with this, I'm done. And this should compile with a lot of linter warnings. I have a typo. Oh, I copied everything, but here's overflow. No. Yeah. So I have a lot of linter warnings. One warning that you're not going to be able to read because I'm not using all my imports. One error that you're not going to be able to get rid of is the shared object. But in this case, it's something that we did intentionally. So we're going to add an annotation so we don't get it every time. You can check more about annotation. It's actually it will tell you which annotations you need in order to suppress the warning. So here's the annotation that I'm going to use. So we have an init. We have a shared object that has an empty policy, the kiosk. Now we need to create a min cap. We need to create a min for the thread cap, but this is going to be gated, so we need a min cap. This I'm going to copy it again from the design doc. And now, usually I like, so the init is the first function I always write, but then I like to group. So it will be like admin functions. Only an admin is allowed to create a min capability. This is a pretty simple function. So but I want to bring your attention here. The min capability has only key, which means that you cannot use public transfer. You need to use transfer. And if you check it in the documentation, it says transfer object ownership of object to recipient. The object that you're trying to send should have only key. And it says this function has custom rules performed by the Sui move bytecode verifier that ensures that T is an object defined in the module where transfer is invoked. So because of this thing, whenever we give only key, whenever we don't give store to an object, if we want to make it transferable somehow, we need to write the code inside this module. If we try to do with any other module, we will get an error. This is the reason that I'm not using the standard way of just returning the cap and then transferring it through the PTB. This would not be possible. I will get immediately a failed transaction. And then the way I do gating, so yes, the way I do gating is that I'm going to actually require as an unused argument the admin cap. So the admin cap is a known object, and I'm sure that it is only one, and only the address that can present this object will be able to call this function. All the others will just get an error. In move, arguments are not optional. You have to give all of them. And now we will have minter functions. So the ones that own a min cap. The first one that I'm going to do is burn or delete. I mean delete. You would have to give the cap to be burned. We can call itself as well. And it's the same. Oops. We need to destructure. Destructuring happens like this. And then we need to delete the ID. So the next function, and the most important function, is public function min. This will allow us, so this will return us trading pack. We want to make sure that this is only callable by someone that has the mint capability. In this case, will be our backend. We will need to know that the rest of the fields and we need a text context because we're going to create a new object. So whenever you create an ID, the shortest way to write it is just trading pack. Whenever we don't have the semicolon at the end, the last whatever we wrote is going to be returned. So in this case, we're just returning this whole thing since we didn't add a semicolon. It needs an ID, object new context, and the tier that we're giving and the season. In this case, the function is pretty simple, but what we intend to do from now on is that this will be called with other functions as well. And as we have seen, I have one, which is called place and list in kiosk. So whenever I'm calling mint, I will want to also call this one in the same transaction. So I create a new trading cup and then I place it directly into kiosk. Again, I want the mint capability, the same person, because I don't want everyone to be able to place items inside my kiosk. In this case, I'm going to need the shared object that I created, because whenever you are placing something inside the kiosk, you need the kiosk cup. I also need a kiosk that is the one that we shared in the init. This would be our kiosk. I need the item that I'm going to be placing, which will be the pack that we just minted in the previous transaction, in the previous block of the programmable transaction block. And the price, of course, since we are going to list it directly. As I said, a good practice is to add the CTX. The call is fairly simple. Kiosk has a place and list, but it needs a type argument. You have to give a reference to a kiosk. I need to present a reference to the kiosk capability, owner cap. I need to present the item and the price. Again, if you're not sure what exactly we're looking for, we can go to the kiosk code and check. In this case, we don't have a return, so we will be guided by the name of the function itself. So Kiosk has a new function that should create new, close and withdraw, set owner, place. So place any object in a kiosk. This would be quite good if we wanted to place in the kiosk. Lock requires a policy. We'll talk about this. Take is take it out of the kiosk. If it's not locked, you can call take. If it's locked, you cannot call take anymore. List, this is the thing that we want to do. List the item by setting a price and make it available for purchase, but this implies that it's already placed. So here it is a place and list. That's a very convenience function, and we see that it needs a type argument that has key and store. So the item that we're going to be placing needs to be tradable. And that's how I got all the arguments that I needed. I needed the kiosk, I needed the kiosk owner cap, the item and the price. Kiosk, kiosk archive, item and price. I'm not going to return this because it doesn't return anything, and I didn't set the return. Let's check if everything builds. Yes, I still have linter errors, but everything is building. That's fairly unusual. And I'm going to create an airdrop function as well. I will copy from the design the definition of the function. And let's make it more readable. A linter is coming soon for move, or I hope it is soon. There are still some issues to be fixed, but we have been promised one. So I need a vector of trading packs. I mostly wrote this address in order to show you from a PTB how you also create. You can create a vector of objects. It's not straightforward. And yeah, the recipient that's going to get the airdrop, because in this case, as we said, we want to wrap them in a non-tradable object. I'm calling it present. Since it's not tradable, it has only key. In this way, the user has no choice but either open the present or just keep it there. He won't be able to trade it. And for this type of object, I will not write a burn function, but I will write the open or unwrap function that will actually do the burning. Of course, I will also require the kiosk for this. Since it has key, you need the UID, and we said it needs to have the packs that we want to airdrop to the user. So this will be a vector of trading packs. So in this case, we need to create a new present. ID. And the packs in this case, which we got them directly because I'm not going to create. The other solution would be to have a standard number of packs, and you could have done something like pack 1, trading pack, and then create the vector inside the function and have 1 or 2 or 3 or 10. But that would not allow you to send an arbitrary number. It would be a fixed number. And since we have the present, we have to do a transfer. Again, present has only keys, so we have to write the transfer inside the module. The present to the recipient. And if this builds, we are done with part 2. Let's try the player function. This will also be the public function, so everyone can call them. One is the unwrap. In this case, we require a transfer policy because we are going to log the items in the recipient's kiosk. This ensures that we are going to get policy every time the item is traded. And since we're locking it, we actually accept the fact that our NFTs will only live within the kiosks that belong to different users. We just have to make sure that we don't write some code that allows a pack to appear as an owned object. And this is a reason for the present. So here I'm destructuring the present. I'm going to be needing the ID and the packs. I'm going to be deleting the ID, of course. And the packs, I would have to one by one log them inside the kiosk. There's not a locked many. This is the usual way that we iterate over vectors. We just check if it's empty or not every time. With Move 2024, we'll have for loops as macros. Right now, only while is available. So we are going to get, we are going to pop back, we are going to pop all the items inside the vector. And then we are going to lock it inside the kiosk. The function is called kiosk lock. And you have to give a reference to the kiosk, the reference to the cap that I'm requesting as arguments. This will be the user's kiosk and the user's owner cap. We have to provide a policy that shows that the item is at least tradable. If a policy is absent, it means that the item will remain locked forever in the kiosk until the creator, which is the person that published the contract that got the publisher, decides to create it as a policy. So this is a reason that we always require a policy to be present before allowing people to lock items inside our kiosks. And here's another part that I want to bring your attention to. A vector can be a primitive and cannot be a primitive in Move. So in Move, primitives are, as we know, are the UA, the U64, all the unsigned numbers, the booleans, and the address. Everything else is not a primitive, so this is a primitive value, but string is not a primitive value. It is a wrapper around the vector of U8. A vector can be a primitive value if it's a vector of primitive values. It's considered a primitive. But if it's a vector of non-primitive values, so of composite or custom values, then it's not a primitive, and we will have to be destroying it. It won't have drop. All the primitive values have copy, store, and drop, so we can just forget about them. But in this case, if we don't destroy the vector, we will get an error. And the code compiles. There is one more player function that I would like to show you. This is the open the pack from Kiosk. So this actually showcases how you can unlock an item from inside the kiosk, whatever you need to do. In this case, I'm just going to be burning it, and in the future version, of course, I will create cards of the trading pack. So in order to unlock something from a kiosk, a trade needs to happen, and the transfer policy that we're going to use should not have the lock rule. So if a transfer policy has a lock rule, the receiver first has to lock their asset that they gained in the kiosk, and then they can actually finish the trade. This is the reason why we created in the init an empty policy. So we create an empty C with no rules. We didn't attach any rules over here. And we are going to be using it right now in order to be able to unlock. So what we're doing actually is we're just selling it to ourselves, to the user that is calling, that is. And . then we're buying it. But since the transfer policy has no lock rule, we are taking by value. We are not requested to lock it back in the kiosk. So we are using the purchase cap just to make sure this is not required necessarily, but it is a feature of Kiosk that I wanted to show as well. You can actually make it so that an item is can be bought only by a certain address, and this is by using the list with purchase cap and then sending this to the address that you would like to buy your item. In this case, we need to provide the kiosk. We need to provide the kiosk cap. Only the owner is allowed to list the ID of the item that we're trying to list, a price. In this case, it's going to be 0, and then a context. Context is because we're going to create the purchase cap. And then we're going to buy the pack. And this is a whole kiosk by, even if it's just list or purchase cap, it doesn't matter. If we didn't want to use the purchase cap, we would use list. This is the whole flow. Maybe sometimes there will be in separate functions and called the asynchronous times. In this case, we are calling them in the same function, but the flow is the same. So first, the owner has to list their item. Then someone who has another kiosk will come and purchase. In this case, with a capability, but it could just have been purchased. In this case, we have to. This would be the new Euros kiosk. In this case, we are selling to ourselves, so we're using the same kiosk. And we need to present the coin of value 0 because the price is 0. And the last part is that whenever we're doing a purchase or a purchase with cap, we are getting a transfer request. This is an object that does not have drop. So we have to destroy it somehow, but the only way to destroy it is called this function called confirm request from the transfer policy module. If we had rules, the confirm request would have checked if all the rules are satisfied or not. So that we would have to do some extra calls first. In this case, we are presenting an empty policy that we have stored inside our shared object. So the transfer request will just be destroyed immediately without any other checks. So now we have the pack by value. We can do whatever we want. In this case, I will just burn it. I don't care about the tire because it's a U8 and it has drop. String also has store, copy, and drop. Let's make sure this builds. Oh. Okay. It builds. We don't even have linter errors. I have one last function. Again, it's a convenience function. You can check it in your leisure. I'm just going to copy paste it right now in order to remain on time. This is how would you min many and put them in the kiosk directly. So I'm doing a while loop where I'm creating packs and then I'm calling the place and list and put them inside there. This can be done from the web to side as well. This is more of an example function. And with this, yeah, let's make more. If it builds, we are done with the contract. Yeah. For our small example, these are all the functions that I'm going to be needing, and I'm going to create an airdrop flow and a primary and a secondary state flow on the Web2 side, and show you how to use the Move SDK. Let's take a 2-minute break here. If you have any questions, please let me know.
Yeah, so for folks that's watching on YouTube, if you understood, let's say 25% of what's going on, type 1 in chat. If you understood like 50%, type 5. If you understood 100%, type 100. I'm curious to see what's everyone's understanding level here right now.
Yeah, if we got a lot of ones, we can go over the contract again, which I believe is the most important part.
Yeah, if you understood like 25%, type 1, 50%, type 5. Okay, what I'm guessing is I think nobody understood what's going on because nobody is typing anything here. Oh, 1, okay. 25%. Catalan, thank you very much for providing that. I think there's also a small delay going to YouTube. What about people on Zoom? Any questions here so far? You can ask directly. You can unmute yourself, by the way. Okay, so I think Catalan just said, I think we have one response so far saying they understood about 25% of what's going on so far. So
so let me take some time to explain in general.
And we also have maybe I would say 40 minutes left, 45 minutes left. So we probably want to kind of think about how we want to wrap this up. So
yeah, sure. So in general, the move contract is just about defining your structs. I use some advanced concepts over here with one-time witnesses, but for a new project, it's not really needed. So you define the structs, and then you define the functions that will work on the structs. If you move, a contract does not have any state inside, so it doesn't remember everything. All the objects that have key will be stored under addresses or will be shared in the global storage. So they will be accessed. So every function that needs to access something needs to take those assets as an input. So everything that has key needs a UID, and then it can have any other fields that we deem necessary. Everything that we want to be tradable, we add key and store as well. And then we start writing our functions. We usually need an init. This is a function that is called only once, like a constructor. You can think of it as a constructor. So all the objects that I don't want them to be created more than once, I'm not going to create any min function for them. For example, the central is a shared object that it's just used to call some state for me, some items that I'm going to be needing. I created only once in the init, and then I shared it as a shared object. But as you have seen, I haven't written any accessors. Another core primitive of move is that, let me see if I'm doing it anywhere. So let's write a quick accessor, public one, let's name it tier, and I'm just getting a pack over here. I need only a reference. So this is a reference, which means an immutable reference. So here I'm only reading a trading pack. If I add the mute in front, is immutable. I can also change something. And here I will just return the pack.tier. And this will be for other functions. If they want to be able to read the fields inside the trading pack, let's remember that a trading pack has a tier and a season besides the ID. So if we want to make this number accessible to any other module, we have to write a function like this. And the reason is that I'm only allowed to do this thing, pack.tier, in the same module that this struct was defined, meaning this one. If I try to do in any other module, if I try to import it in admin and press pack.tier, I will just get an error. That being said, so every move module, you define your structs and you define how you want them to be accessed or created. I define a min cap. I define a min function for it since I want it to be created. In this case, it will be created just under certain by a certain person, by a certain address. It's the address that owns the admin cap that was made in another module. I define a function to delete the min capability. Then I have a min function from my main NFT. This will return a trading pack. Here I just create it and return it. And since we're going to be using Kiosk, I wrote some helper functions that allow me to put items inside the kiosk. A kiosk is a shared object. As you've seen, it's usually a shared object. If you want to be usable, we have to share it. And it's just like this one. Inside it, you can put other objects. But every kiosk comes with a capability itself. It's called the kiosk owner cap, which means that, and the code is written in such a way that only the user that has this capability can actually do stuff on kiosk. So kiosk has a bunch of stuff that you can do. You can do list, place and list, lock, or even take and place. All these, if you check the code, require the capability. And there are only two functions: the purchase, that does not require capability, which means that everyone can call it, and the purchase with cap. So the kiosk itself is a shared object, as I said. You can put objects inside, and then you can list them for sale. Now, the reason that we introduced Kiosk is that it has a very loose dependency to another object that it's called transfer policy. A transfer policy is an object that is created by the creator of a new asset. So whenever I create a new asset, I'm allowed in the init to get a publisher object, and this will allow me to call the transfer policy new. Whenever I create a transfer policy, then I'm also allowed to add rules to it. The most common rules are the royalty rule, and there I can define how much royalties I want for my assets, and the lock rule, which will ensure that the objects will live inside the kiosk, so I will not allow my assets to be traded outside of a kiosk. The combination of these two rules ensures that you will get royalties on every trade. And that's about it about the function. I have some airdrop, and the only vulnerable part over here is on the mint. When I first mint, if I want to airdrop, if I send directly, I could just have send like transfer the pack, a new pack to an address. But in this case, it will be up to the address if they want to lock or not the item in the kiosk. I didn't want that to happen, so I used a pattern where I wrap the trading bags that I'm minting inside an object that is not tradable, and then I force people if they want to get rid of that object that I'm sending them. I only give them one way to do that, and this is the function that is called unwrap. I hope that this clears something up, a few things up, but keep this code in order to reference it and see some patterns after you check out the more basic documentation.
Yeah, so I'm going to also link the repository that Alex is using to the video description. So once the live stream ends, you'll be able to see that as well. We'll have maybe about 30 minutes left. So Alex, I'll let you decide how to wrap this up.
Yeah, I will continue with the transactions themselves that I want to be called. So I will create a script module, and inside here I will have an env, which I'm going to be needing. In this case, in my case, I will only have an admin key. This will be the backend that it's allowed that will have the publish the contract, and also will have the admin capability, and will create a mint capability for it, and will be allowed to mint trading packs. But except that, I'm going to download two very important packages. One is the admin Sui.js, and the other one is admin Kiosk, which is the Kiosk SDK. Of course, we're going to install the types for Node in order not to get any errors. I'm going to be using TypeScript. So we have a package JSON. I have everything that I need. Oh, I'm going to install .env as well in order to be able. Since we don't have a lot of time in the full code, I have a publishing script where it allows me to publish. In this demo, I will just focus on the transactions themselves, how I can build transactions, and how I can call the functions that I just wrote in the move contract. So why do I need the constants? Usually we also have a file. In this case, this will be populated by my publishing script. I'm not going to do right now, but here we are going to save some variables that are not going to be changing, some constants, mostly like the package ID that the contract was published, and the network maybe that we're using. Let me actually copy it. The way I have. So these are some data from a previous publish I need the package ID. I need the shared object. I need its address where it went. I will need my admin cap, the min capability, the publisher if I want to create new transfer policies, and the transfer policies that were created. And the kiosk that it's our kiosk. So let's go to the transactions. And let's call every function that since we don't have a lot of time. One function that we have over here. The first function actually is the mint the capability. So the way to call it is we import the transaction block from instance.js transaction, and this will allow us to do as many move calls as we want. So for one single function, we have to do a single move call. We have to give it the package address that we got, the module. Here the module is called, I haven't defined it. So I'll keep them, this is global variable. So the module is called trading pack, right? So it's the module, and then the name of the function. The name of the function is over here, min cap. Afterwards, we will have to give the arguments and perhaps the type arguments that are needed. In this case, we don't have type arguments. The arguments, again, we can check the move code. It needs an admin capability, a recipient, and the context. The context is given by the move engine itself, so we will never have to add it. We only need to put 2 arguments. In order to pass an object that it's in the on move on Sui, we do the transaction block that object and we give an address. In order to pass a pure, which means a primitive value like an address or a U8 or a vector of U8, we do tx.pure.type. So if you want address, it's that address. If you want U64, it's that U64. And we'll see how we'll do that for vectors. Here I'm returning the tx because I want them to use. I want to use them inside flows. But if you wanted to actually call it, you would need a signer. I will show you how to do that, or it is in the code. So I would like to show you how you do the airdrop, because inside the airdrop, you will have to create a vector. So let's go with the code over here. So I have a function called airdrop to many. I will need the min capability. I will need to know the tier and the season of the package that I'm going to make, the addresses that are going to be receiving, and the amount that each address is going to be to receive. In this case, I'm going to only give one asset per address. So there are some transactions limit that you may hit if you add many addresses. In this case, you might need to do more transactions block than one, as I did in this case. This is just a more, but if you're less than 300, so the limit of the transaction is that you can only do tx.move call or any other command up to 2048 times, and you can add the most 1024 objects. In this case, since I'm going to airdrop, I'm going to need to call for every airdrop. I need to mint first the trading pack, and then I need to call the airdrop function, which is over here. So, and also I will need to create the vector. I will need to put every trading pack inside the vector. So these are 3 commands, and that's why I said 300 players. The limit is 2048. I like to keep it a lot slower, so this may actually work for even 500, but I just want to make sure, so I just said 300 players at a time. So for every address that I have, and I'm just making sure, so if address's length is more than 300 or more than 512, so the theoretical limit is, I think I'm wrong over here, it's 2048 and 1024 objects. The limit could have been bigger. I'm just chunking the address, so if there are more addresses than 512, I will just create as many transactions block. So I will create a transaction block for every 512 addresses, and then I will create a new trading pack, and I will put it inside a variable that is named pack, a vector that's named pack. The important thing that I wanted to bring your attention to over here is that since I have a vector of objects, you cannot just do a tx pure or tx object or something like that. You have to call the tx make move vector. So this will create a vector that it's made out of objects, and we give the type of the object. A type of an object can be found over here at the definition. So I have trading pack. The type of the object is the package ID. In this case, it's Overflow, but when I publish it, it will change to an ID that starts with 0x. It's the module's name, trading pack, and then it's the struct name. So it's package ID, is the module name. Oh, sorry, it's the package ID, the module name, and the struct name that is trading pack. So this will be the type of the object that I'm going to put inside the vector. And here are the objects, all the objects that I created above, and I push them back into the pack vector. So I will create as many mints as this number. In this case, I'm just, by default, it's 1, but as many mints as I set over here. And then when I'm done with all these mints, I will, and the pack is created, I will make a pack vector, and then I will just call the airdrop. The airdrop function means the mint capability, the packs that I'm going to send, and the recipient. So it's the mint capability, the packs that I'm going to send, and the recipients inside the arguments. And since we don't have a lot of time, I will also try to show you how you do the airdrop. How do you finish the whole flow? This usually should appear on your backend, so these transactions make sense to be all grouped together. Maybe you want to have all the transactions over here that return your TX or TXs, depending on how many you have. But the rest will just happen. This flow, should be flows, will be integrated in your code, in your React code or Vue code, depending on which framework we're going to use. Sorry. So I don't have the utils yet. Let me show you the utils, how you create. So here's how we create a client. This client is able to do all the reads that we want. So if you want, we can do client get get on objects. It doesn't show it here for some reason. So get on objects, get balance. All these are valid. It has a lot of, the Sui client has a lot of functions that allow to read everything, and it also allows us to execute transactions. Over here, I have the example. So if you'd actually do a cat, if you have installed Sui and you check there is a hidden folder called Sui, and inside is Sui config, and inside it has a Sui key store, and here all your private keys are being saved, and they are saved in base64. So if you have the value over there, I took a value over there and put it in my env. So I take the admin key from my env, and this is the way that you actually create it into a key pair. Because when you take the base64 and you decode it, the key has a flag in front. So the flag is the first byte. The first byte can be 0, 1, or 2. And depending on which, it's a different scheme of key pair. So if the flag is 0, so if the first byte of the translated base64 string is 0, then it means that we have this key pair, the address curve, the ID 25519. If it's 1, is the SCCP 256K1 or R1, if it's flag 2. So as soon as I have a key pair, I can see what is my address, and then I can call the sign and execute. So you can do client, sign and execute transaction block. You give a transaction block that you have created as we created inside the transactions. You need to give a key pair, which we create over here. This is for the backend work. And then you can have some options. All the options of a transaction are show effects, show object changes. We want to see object changes. It has show events if we have events. And the request type, wait for local execution, is the best one if you want to get a full response. Yeah. If you're trying to sign for a user, then this sign and execute transaction block, instead of client, you would integrate with the instant dApp kit, and you would get a wallet. So you would import the use current account and from a hook, and that hook will return you a wallet. And this will allow you to just call wallet, and that's we sign and execute transaction block. And whenever you call that, the user will get a pop-up from his wallet. You're trying to do a new transaction. Do you accept or do you reject it? But the inputs are the same. You have to give the transaction block. You won't be needing to give the key pair because that's hidden inside the wallet, and the options that you want, or depending on what you want to see in the response. So now that I have all of this, so I have the client and the sign and execute. So this is just a mock. Especially for airdrop is something that we need because this is an admin. This is something done by the backend. So this is actually correct. In this case, I'm just calling the airdrop to many that I just wrote. I give it the min cap that I'm supposed to give. It's season 3, and the name is the tier is 3. The name of the season is called Prelude. The addresses, again, again, this is supposed to be written in your backend, like it shouldn't be a standalone function. Actually, you will have a list of addresses over here and the amount that each player is going to receive. And then you just call airdrop to many. It has a lot of transactions inside, so it's a vector of transactions. Thus, we just call sign and execute each one by one. And then we have the user, which it should be a wallet sign and execute. This here is going to be imported from the Mist and dApp kit. For the unwrap, I'm using the Kiosk client. This is the Kiosk SDK. From the Kiosk SDK, you just write a get on kiosk and you give the address of the user. This will return you all the kiosk IDs and the kiosk owner caps that they have. In this case, I assume that there's only a single kiosk. I'm writing it over here, but there's also possible to check if there are many kiosks. You can actually choose each one you would like. And then I do an wrap airdrop, which I haven't written yet over here. It is a function that is the transaction that's actually calling the unwrap from my move code. So yeah, I need the present address, a kiosk address, the kiosk app address, and the policy in order to unwrap, because the move function at unwrap requires those things: present, kiosk app, and policy. So I create a new transaction block, and then I say a move call, please unwrap airdrop. This would fail because I named it unwrap over here. So it's called just unwrap. This is the function that I'm trying to call: package, module name, and then function name, and the arguments are present, the kiosk app. All these are addresses: 0x, 0x, something, big hex, and we have saved them all in the constants. In this case, in order to see how that was gotten, you can just check my code. And when I did the publish, all these things were there, and I have over the two flows that create the transfer policies. So for the airdrop flow, what would happen is that an admin, a job at one point in your admin dashboard, this function would be called from a button. The admin should have actually put the addresses. You should have a UI that has a table. You put all the addresses inside. You give the amount that the addresses are going to get, and then it would have just called this function. Of course, here I have hard-coded it. This is a mistake. I have hard-coded it, the season and the... So I could have asked for them as well. So I could have said here, number and season. And I could have just waited, expected this information from the UI. I create I get all the transaction blocks. If the addresses are less than 512, I will get only one, and sign and execute with the address private key. And then for the client side of my UI that the user sees, there should be a there should be a pop-up that says, oh, you got a new present, you got an airdrop, press here to unwrap it. Whenever he presses that button, this function will be called, and it would be the user address. We need the user address, and we need the ID of the present itself. So we would get from the address, we would get the kiosk that the users own. We would check in which one, or we would ask the user to indicate the kiosk. So we take a kiosk at random. I took the first one. I am going to unwrap the present and put them inside every trading pack that he has. I'm going to log them inside the kiosk. Seeing that we have no more time, I will stop here. Please check the full code. And you can find us anytime on Telegram, on the Sui Nami Rider channel, or some other dedicated channels. Just tag me. It's Alex_Sui, and I will help you answer any questions that you might have with this code.
Oh, thank you very much, Alex, for the workshop here. I think I'm going to, I guess before everyone go, if you're still following, very big thanks from the Sui team for following along. I think Alex is also showing like a little demo here on what it could be if you built out a kiosk primary market, secondary market, using the some of the code that he has written there. So the front end code is, go ahead.
This is courtesy of UZ, so this was written by Z, in order to show, but it actually calls all the flows that you will see in the code and transactions themselves. So we have a buy, and we have a list. Oh, sorry. We have a list for sale for the user. These are the items that were listed in the secondary market. The primary market, this is just the primary kiosk that we have, and all the packs that were minted by the admin. You can just press buy, approve, and when the transaction is executed successfully, you will see that I have a new object that I can list for sale from then on. Thank you very much.
Yep, thank you. So if you're still watching, I think we are looking for feedbacks there. So let me try to give a feedback form here. I think it will take you maybe 2 minutes to fill out the things, but we will really appreciate if you can kind of help us out on producing more engaging content. So it's this link here. I'm going to leave the link here for another 2 minutes or so and then end the stream. But yeah, thank you very much, everyone, for joining. Also experimenting with us on this new form of workshop. And I understand that the workshop in the beginning, we had some technical issues, and then that kind of cut into some of the time there. The presentation itself, I guess the workshop, it's a big project, so we had to rush some part of it. So looking forward to everyone's feedback there, and hopefully I'll see everyone in the next workshop, which will be tomorrow at about the same time, I believe. And I'll see everyone there. I'm going to end this Zoom video as well. All right. Bye, Alex.
Bye-bye. Thank you very much. Good luck at the hackathon to everyone.
Yep.